Everybody's excited about vectors, right? I mean, I think that's like the buzz that's in the air. I mean, what could be more exciting than something that has like a magnitude and a direction, right? Yeah? You see how I just kind of worked into that? Hey, now we're, right? Okay. So if somebody says, they give you a coordinate like 8 centimeters in the x direction, hey, that's a vector. 8 centimeters is the magnitude, and the x direction is, that's a direction, yes? It is, isn't it? Okay, and we all agree, I think, that the x direction is to the right, or it's 0 degrees on our little trigonometric circle, or it's 360 degrees, yeah? Right? We could also talk about 18 centimeters at 320 degrees, and that's a little more difficult. We could picture that, right? This is 270. 320 degrees is actually 30 and 20, so it's like something like that, isn't it? Is that right? Is that 320 degrees? Is that angle 320? Something like that. Okay. It's only 40 degrees away from 360, right? Okay. So we're going to think that way, right? Okay. We could also have a velocity, 27 meters per second, due south, right? That's how I drive to Tualatin, something like that, right? Okay. Or more excitingly, you could launch your air rocket at an angle of 35 degrees bearing, yeah, right? Okay. At a 35 degree angle with the horizontal, right? That'd be sort of more exciting, right? And then of course, there's a force vector, right? So anything that we care about the magnitude and the direction, which is just about everything in physics, but not everything. Like mass is not a vector. We don't have 5 kilograms in the north direction. So I don't think we do, right? Temperature is not a vector. We don't have, it's not 17 degrees Celsius north here, or something like that, right? But most things are vectors, right? Okay. And there are 3 handy truths about vectors. The first handy truth, you already know, but I'm going to tell you, and then I'm going to pretend that I taught this to you. If you want to reverse a vector, just multiply it by -1, right? So if this is positive A, this is negative A. Positive, negative. Positive, negative. This is positive B, right? If that's positive B, then negative B is this way. It's crazy, right? We just multiply by -1. And we'll do that, by the way, we'll only do that with vectors that are in the x or y direction. That's appropriate. We're never going to say, I'm never going to say, this is a 30 degree angle. I'm never going to say this, 30 degrees. That's not fair. That's not polite. Okay, I'll always slide the thing down here and then give you a proper angle, kind of a thing like that. Okay, so don't be reversing things that are at some funny angle. So that's handy truth number 1. Are you guys ready for handy truth number 2? Okay. If you want to add vectors that are parallel or anti-parallel, parallel or anti-parallel, parallel, they're different, aren't they? Aren't these different? I always have some kids that go, no, they're the same. They're both parallel, right? Yeah? They're different though, aren't they? Do we all agree? That's parallel. This is anti-parallel. If they're vectors, there's a difference. If they're lines, then they're not. There's no difference, right? I always wonder, because kids that argue, like they're adamant about it, right? Right. I don't want to get on the freeway with them. Right? You ever hear that joke, right? The woman's husband is driving home on the freeway, right? And the wife calls him up while he's driving. This is against Oregon law, right? Calls him up while he's driving. He says, honey, look out. There's somebody driving the wrong way on the freeway, right? And he goes, one person, there's hundreds. Yes, there we go. So an example of this is if you have 8 centimeters in the x and -3 centimeters in the x, those are anti-parallel in this case, right? A plus B is just simply 5 centimeters in the x. In fact, if we drew a picture of that, it'd be like this. It'd be like, let's go over 8, let's go back 3, and there's 5, right? Yeah, the answer is plus 5 in the x direction, right? Okay. By the way, does it matter which order I do these in? Could I go -3 first and then +8 second? Does that matter? Doesn't matter, does it? Yeah, there we go. So that means that these guys at least are commutative. Commutative means it doesn't matter what order you do it in. You guys ready for the third truth? Are you ready?
Yeah.
I know. To add non-parallel vectors, that is ones that are not parallel or anti-parallel, right? Okay? The ones that are askew, but I didn't ask you. Okay? What you want to do is you want to place them tip to tail. Right? So if that's A and that's B, A plus B looks like that. Yeah? Okay, so here's A, here's B, and then A plus B is this. Do these ones matter which order we do them in? I know it's like one answer makes our life easy, the other answer makes our life difficult. So let's just try it in the other way. Let's go B plus A. This was A plus B. We did A first, then B, right? So B plus A is we do B first, and then we do A. It's the same place, right? And then we end up in the same place. Isn't it the same answer, right? So even if they are askew, if they are like non-parallel vectors like that, A plus B equals B plus A. This is a good thing. Isn't that a good thing?
Yes.
Yeah, that's good. It's like, darn, I don't remember what order. It doesn't matter. Okay? And the reason it doesn't matter is that these guys are parallel, correct? And they are congruent in length, yes? And therefore it's a parallelogram, and I don't know. It's not really a proof, but it makes sense. Yeah? Tip to tail. I mean that the first vector's tip, when you're adding them, you place the second vector right at the tip of that one. Yeah? You don't place them like this. Don't do this. Right? Just think like you're taking your dog for a walk and it meets another dog. It's like this, or it's like that, isn't it? Right? Actually, there's some of this too, but mostly anyway. It's like, why is that? Okay, what if you have to subtract vectors? What if you have to subtract vectors? Well, some books will tell you to place them tail to tail. I will never say that. I say just simply add a negative. So if that's A, that's negative B, correct? That's B, that's negative B. Okay? And then A plus a negative B is the same as A minus B. Yeah? I should work like an S in there, and then we'd have like A, S, B or something like that, right? Okay. And there's A plus a negative B. And some people are disturbed by the fact that A minus B is longer than A plus B. That's the mystery and the beauty of vectors. Huh? Huh? I think that's just an amazing thing. Yeah? And then the final thing that I'll give you is that there are two types of vectors. There are two types of vectors out there in that wild world, okay, that we're going to deal with. Some of them I call angle magnitude vectors. Okay? Angle magnitude vectors. And angle magnitude vectors have an angle and a magnitude. Right? So it's like this guy right here, right? 36 degrees and 8.0 centimeters. Yeah? That's just an angle and a magnitude. And those are the ones like this that could be like off at any angle. Right? And then the other kind of vector are called vector component vectors. Right? And a vector component vector, what we do is we pretend like we have an Etch-a-Sketch, right? And we say how much x is there and how much y is there, right? So I could maybe represent this vector with a certain amount over and a certain amount up, like that, right? So I could go maybe 4 centimeters in the x direction plus 3 centimeters in the y direction. And you always write it that way, okay? Something units and then x, and it's like x with a little hat on it. For the people in the back row, that's what I wrote. Yeah? Okay. And then it's some amount centimeters in the y direction.